The real numbers, all the numbers that we know about, are split into two groups. We have a group called the rational numbers, and we also have a group called the irrational numbers. The irrational numbers are probably the numbers that you are more familiar with. We have the set of numbers called the natural numbers. So I'm going to put the natural numbers into this Venn diagram. The natural numbers are the counting numbers, 1, 2, 3, and so on. And then if we add 0 to this set of natural numbers, we get the set of whole numbers, 0, 1, 2, and so on. And then if we add to the set of whole numbers the negative whole numbers, we get what's called the set of integers. So the set of integers are all the positive whole numbers, all the negative whole numbers, including 0. Those are the integers. So we have natural numbers, which is just 1, 2, 3, 4, 5. We have whole numbers, which are 0, 1, 2, 3, 4, 5, and so on. And then we have the integers, which are all the positive and negative whole numbers, including 0. And then we also have some rational numbers that are not integers or whole numbers or natural numbers. And those would be the numbers that can be written as a fraction. So that would include something like 1/2, maybe 0.3, which could be written as 3/10, or even 0.6 repeating. 0.6 repeating could be written as 2/3. Also, maybe a mixed number, like for instance, 2 and 1/2. 2 and 1/2 is not an integer, but it is rational because it can be written as 5/2. So what are included in the rational numbers? All the numbers that can be written as a fraction. So that would include, let's make a list. That would include the integers, which are all the integers and whole numbers and natural numbers. We have fractions. We have terminating decimals, like 0.3. Remember, 0.3 can be written as a fraction, 3/10. We have repeating decimals. Repeating decimals are like 0.3 repeating, which is 1/3, or 0.6 repeating, which is 2/3. And then also mixed numbers. Mixed numbers can be written as improper fractions. We know that. Okay, so if we take we need to talk about irrational numbers. I almost forgot. Irrational numbers are the real numbers that can not be written as a fraction. So that would include a couple of things. Let's see. You learned last year about the number pi. The number pi is an irrational number, which we use when dealing with circles. And pi is approximately 3.14. We remember that. That is an irrational number because it is a non-terminating and a non-repeating decimal. So if it's a decimal that does not terminate and it does not repeat, then it is an irrational number. In our class, we're not going to talk about pi as much as we'll talk about square roots that are not rational. For instance, the square root of 2. The square root of 2 is an irrational number. If we punch the square root of 2 into our calculator, we will see a non-terminating, non-repeating decimal. Okay, so if we can take rational and irrational numbers and we can graph them on the number line. So I'm kind of expecting that we know that 0 is in the middle of the number line, and the positive numbers are to the right, and the negative numbers are to the left. And it goes something like this. So let's see, where would we put negative 4/3 on the number line? Negative 4/3 is also known as negative 1 and 1/3. So negative 1 and 1/3 would go about right here. So we would put negative 1/4 there on the number line. The square root of 2, let's see, if we open our calculator, we can see approximately what the square root of 2 is. We'll also see that non-terminating square root of 2, that non-terminating, non-repeating decimal. Notice how it's a big long decimal, goes all the way to the end. It doesn't repeat, and it always stops because your calculator runs out of decimal places. So it's about 1.4. So I'm going to go back to the number line, and about 1.4, I'm going to put the square root of 2. And 2.7 is almost a little over halfway between 2 and 3. Okay, so that's not difficult. Let's look at the next example. The next example says your school is sponsoring a charity race. Which set of numbers does not contain the people P who participate in the race? So let's see, how many people could participate in the race? Let's see, the natural numbers are 1, 2, 3, 4. So could one person participate in the race? 2 people, 3 people, 4 people? That would make sense. What about integers? The integers would be the negative numbers and the positive whole numbers. So could negative 7 people participate in the race? I don't think so. So we're going to cross that out. The set of rational numbers. Let's see. Rational numbers includes fractions. So could a third of a person participate in the race? And the answer to that is no. And let's see, irrational numbers. Could the square root of 2 people participate in the race? And the answer to that is no also. So I only think that there could be 1, 2, 3, 4, or 5 people. So the set of natural numbers would be the one that makes the most sense. So we're going to spend just a little bit of time talking about some properties for real numbers, properties that I'm sure that you've heard of before. The commutative property says that if we switch the two numbers and we're adding or we're multiplying, it does not change the sum or the product. So an example of that would be that 5 plus 2 is the same thing as 2 plus 5. An even more complicated example, maybe a little bit harder to see, would be that 5 plus 2 plus 3 is the same as 3 plus 5 plus 2. It's the same thing. The associative property has to do with grouping. If we group 2, we have adding 3 numbers, or if we're multiplying 3 numbers, the grouping, the way we group them, which ones we add first or multiply first does not matter. So an example would be 3 plus 2 plus 5. If I add 3 plus 2 and then add 5, I get 10. Or, let's see, if I add the 2 plus the 5 first, I get 7, and then I add the 3, I also get 10. The identity property has to do with what do I need to do to a number to keep its identity. Do I need to add 0 to it? If I add 0 to a number, it keeps its identity. So 5 plus 0 is still 5. And if I multiply a number times 1, it keeps its identity. So 5 times 1 is still 5. We all knew that. And we need to remember that it's called the identity. So this is the additive identity, and this is the multiplicative identity. And then we also have a additive inverse. The additive inverse says that when you add opposites, you get 0. And the multiplicative inverse says that when you multiply a number times its reciprocal, you get 1. So in opposites are what you add together to get 0. And reciprocals are what you multiply to each other to get 1. And then we have the distributive property. We all remember about the distributive property. If I need to add 5 times a plus 3, that's the same thing as 5a plus 5 times a plus 5 times 3. Reminding you of the distributive property. Fix that. Okay, and then lastly, we have the closure property, which just says that if I add two numbers together, if A and B are real numbers, then if I add A plus B, I still get a real number. And if A and B are both real numbers, if I multiply A and B together, I will still have a real number. That's called the closure property. So let's see if you can answer these examples. We've got the first one that says 3 plus 9, and then a plus 8 is the same thing as 9 plus 8 and then plus 3. That, I believe, is we're going to say the additive associative property. And 1 over 32 times 32 over 1 is the same thing as 1. So I know that 1 over 32 and then 32 over 1 are reciprocals. And that makes me think of the multiplicative. We're going to write multiplicative, which is different than additive. Multiplicative inverse. And then when I multiply, looking at example 3 now, when I'm multiplying 8 times 1, and I get 8, it's keeping its identity. So this is the multiplicative. One more time, I'm going to write multiplicative identity. Notice every single time I wrote whether it was additive or multiplicative. And then for number 4, I've got A times B times 5 is the same thing as 5 times AB. So that's a tricky one. Notice how the AB and the 5 are switched. So they are traveling, they're commuting. That's the commutative property. So that is the multiplicative commutative property. So I'm expecting that you know how to recognize these properties.